and hi, I am Shazliana and I will begin this video presentations. Safety is an important aspect of every home, especially in areas such as staircase. Many houses still rely on manual lighting, which may increase the risk of accidents when lights are forgotten or not switched on. So, we introduced motion sensor Stair Light, a smart lighting system that automatically turns on when motion is detected and switch off when no movement is present. The system improves safety, enhances user convenience, and reduces energy consumption, supporting the concept of smart home security system.
Next objective. We have three objectives for this project. The first one is to design and develop a motion sensor Stair Light system that turns on lights when motion is detected. The second one is to eliminate the need for manual switching, increasing user convenience. And the last one is to reduce energy consumption by automatically turning off when the stair is not in use.
Next is digital collaboration tools. First, YouTube. YouTube is used as our main learning platforms for motion sensor lights tutorials. It provides clear visual demonstrations, coding guidance, and help us understand both basics and advanced system implementations. Second, WhatsApp. WhatsApp serves as our primary communication tool for team discussions and update when we are not physically together. It allows us to share progress, exchange ideas, and ensure all the team members stay informed and involved. The last one is Arduino IDE. Arduino IDE is used to write, compile, and upload codes to the Arduino Uno. It enables communications with sensor and hardware components, supports automation, and simplifies system development.
Next is approaches and techniques. For this project, we have 5 steps. The first one is connection between power supply and microcontroller. A stable power supply is essential to ensure the microcontroller functions continuously and reliably. In this project, the Arduino microcontroller is powered using USB power source. This provides sufficient and consistent voltage, allowing the Arduino to properly manage the motion sensor and LED lighting system without interruption. The second one is connection between motion sensor and microcontroller. The motion sensor is connected directly to the Arduino microcontroller to enable the detection of human movement near the staircase. When motion occurs, the PIR or IR sensor generates an electrical signal which is transmitted to the Arduino through its input pins for further processing. The third one is motion detection process. Motion detection is used to identify when a person approaches or uses the staircase. The motion sensor continuously monitors the surrounding area. Once movement is detected, the sensor sends a signal to Arduino, indicating the presence of a user on the stairs. The fourth one is LED lighting control. The LED lights are automatically activated to illuminate the staircase when motion is detected. Upon receiving the signal from the motion sensor, the Arduino processes the input and sends an output signal to switch on the LED lights. When no movement is detected for a certain period, the lights automatically turn off to save energy. The last one is automatic lighting system operation. The entire system operates automatically without the need for natural switches, improving both convenience and safety. The Arduino program controls the sequence, timing, and duration of the LED lighting based on sensor input, ensuring efficient, hands-free, and energy-saving operation.
Next, I will explain to you the responsibilities of each role in our project. The project manager plans and manages the project schedule, coordinates team tasks, and monitors the progress to ensure all objectives are completed on time. Next is the software engineer, who programs motion sensor Stair Light, integrates the software with sensor and LEDs, and performs testing, debugging, and documentation. Next is the electrical engineer, who handles hardware setup and wiring on the breadboard, troubleshoots hardware issues, and ensures the system operates safely and correctly. We also have designer to create physical layout of the system and prepare sketches or prototype to support functionality and easy maintenance. And lastly, we have research and development role to focus on researching motion sensor, stair lighting, and IoT concepts. Also, testing sensor placement, evaluate system performance and suggesting improvements.
There are 8 components that we use in our project.
The first one is the Arduino Uno, which is the main controller of the system. It connects the sensor and LEDs through its digital and analog pins and is programmed using the Arduino IDE. Next is the IR sensor, which detects motion by sensing changes in infrared radiation. When a movement is detected, it sends a signal to the Arduino to turn on the LED light. Next is resistor, which control the electric current in the circuit. They protect components like LED from damage and help ensure the system works safely. We also use the USB cable to connect the Arduino to a laptop to provide power and allow code to be uploaded. It also enables testing and monitoring through the Arduino IDE.
Next, the breadboard. The breadboard is a reusable and solderless platform that we use to build and test our circuit. It allows us to easily connect components like the LED and jumper wires. This makes the circuit simple to modify during testing and help us save time during development. Next, LED light. The LED light acts as the output device in our system. It represents the staircase light. When motion is detected by the sensor, the LED turns on automatically, and when there is no movement, it turns off. This helps demonstrate how automatic lighting can improve safety and reduce energy usage. The jumper wires are used to connect the Arduino Uno to the breadboard, LED and motion sensor. They allow power and signal transmission without soldering, which makes the circuit flexible and easier to troubleshoot if there are any issues. The last component is laptop. The laptop is an essential part of the system because it is used to write and upload the program to the Arduino Uno using the Arduino IDE. We also use it to test and debug the system through the display window. This project showcases a smart staircase lighting system using IoT concepts to enhance safety and energy efficiency. The IR motion sensor detects human movement and sends a signal to the Arduino, which then controls the LED lighting. The light only turns on when the sensor detects a motion. Through this project, we learn the importance of proper wiring, correct sensor placement, and basic Arduino programming. The system successfully meets its objective and has potential for future smart home lighting applications.
The staircase motion sensor IoT project successfully met its objectives. The system automatically turns on the LED when motion is detected, improving safety, convenience, and energy efficiency in low light areas. It reduces the need for manual switching and operates reliably when powered. However, the IR sensor's range and sensitivity can be affected by environmental factors, and the current LED may not provide sufficient brightness for the real staircases. For future improvements, the system could control actual staircase lights with relays or smart bulbs, include a timer to turn off lights automatically, and integrate with IoT platforms or mobile apps for remote control and monitoring. These upgrades would make it more practical and user-friendly for smart home applications.